Hello everyone, this is Mr. Khan from Pakistan. Today we are going to talk about Frida, which is a cross-platform analyzing and somewhat you can call it a reversing tool, which can be used for analyzing binaries of which you don't own source codes, such as games and applications of other people. You can analyze it for fun, for educational purposes, as a way to assess you and help you in understanding certain things when you are learning reverse engineering as a profession. So the first thing that you must remember is you must install Python in your PC. Okay, and the way that you are going to do is by going to Python download and go there, and you see the first link here. You just click it and it will download Python for you, and it has automatically detected I have 64-bit PC. It is downloading this, and you can start install it automatically. And after installation, if there are any command prompt windows open like here, you need to close all of those. After that, you can spawn another fresh window of command prompt, and there you can type Python minus capital V. Okay, and if you see this prompt here showing Python this version is installed, it means that the setup is complete. If it doesn't show you this thing, and if it starts or launches Microsoft App Store, and it shows you from where you can install Python as an app for Windows, then it means that the Python that you have installed is not compatible, or there is some problem in the installation that you need to check. For example, in the start of the installation of Python, it is required that you add it to path. How you will verify if the Python is added to path? You just type path here, you click edit, you go to environment variables, double click the path here, see, and then you just go down and see if there is anything mentioning Python here. Okay, so here is Python 3.7, Python 3.7, and these two folders must be present here as Python 3.7, Python 3.7 scripts. Okay, and you can also check this path here. This must also have these two paths. This 3.7 can change for the version of Python you have installed. I have 3.7 because I'm using IDE 7.7, and it is the requirement for that version. The next step, after verifying everything and spawning a new Python window, or a new command prompt window, you should install, you should first check if pip is installed. And if you just type pip here and you see this prompt, it means pip is installed already. Okay, then you have to install Frida from here for Windows, because you will be using Windows as the base platform for analyzing binaries on other architectures, such as on emulators on your mobile phone, or on on things which are already on Windows. So you just go there, pip install Frida. Okay, and it says requirement already satisfied because it is already installed in my PC. And then you just go do the next Frida tools. Okay, and it says requirement already satisfied, so it means Python is telling me that Frida and Frida tools are already installed in my PC, right? The next thing to check if Frida is installed properly is by typing Frida. Okay, and you see this usage Frida options target and Frida error target must be specified. It means Frida is installed and ready in your PC. The next thing, you must decide on which platform you are going to be reversing or analyzing binaries. Most people don't have rooted phone, because rooted phone is required for analyzing binaries with Frida. But if you don't have a rooted phone and you still want to use a mobile phone, then there is another way. We will talk about those different methods, how to use Frida on your mobile phone, and also how to use it on emulators which are rooted, like LD Player, Mimu, BlueStacks, etc. So the first thing in this, we will talk about how to use Frida on LD Player. Okay, how to install it. You must open or install LD player. I am using 5 version. You can use any version, but I prefer 5 because it is bug free. It has been developed over a long duration of time, and it is suitable for these things. You go to settings, and inside other settings or network settings, this should be disabled. In other settings, you should have root permission enabled, ADB debugging, open local connection, and after saving these settings, you should close and restart LD player. When LD player is restarted and you are already in the home screen of LD player, so inside LD player, when everything has been the root has been set up, you should check which architecture this emulator or other emulators are in. Okay. Normally emulators are x86 based devices, okay, or platforms, but you can also check it very easily with this command by typing this command and it will show you a list of ABIs which it can support. The first one, the x86, or if it is in the second or the third one, the order doesn't matter, but if the list contains x86, then the device must be considered as an x86 based processor or processing device. Okay, it can support ARM 32-bit and the ARM basic version. This is ARM 32-bit v7a, on which our game like PUBG, Honor of King, and these things are, Free Fire, etc. These are based. So it can support the 32-bit standard version of the Android operating system, but the processing capability of this emulator is x86. It means that if you are going to use Frida on this device, you must download and use something that can translate code and memory for you from x86 to ARM, or whatever the architecture you are analyzing it on is based on. Okay, so for that purpose, just go to Frida GitHub. We now know that the architecture is x86 based. Go to releases, and inside you should go to show all, and then there are like Frida, and there are things like you should focus on core dev kit. We don't need this. There are gadgets are different things. There are gum dev kits, and there are other things like inject portals, servers, etc. So the way our analysis will carry on is we will have Frida here. This will act as a client, okay, and in the device we will have a server which will communicate information from this device into our PC through this console or the ADB channel or socket channel. It means that you need a server that we can install inside LD player and run it, and then the analysis can be shown to us based on our scripting capabilities in the console in our PC. The same thing can be done for like if you don't have a laptop and you want to use Frida inside mobile phones with Termux, you can install Frida like that, just as I show to you in the start of the video, inside Termux with pip install Frida and pip install Frida tools, and then inside your device you must check for ABI. It will show you ARME ABI x64, okay, or V8A, or whatever is the thing, the processing capability of your mobile phone. Based on that information, you can download Frida server and you can install inside your device in data local temporary, and the same thing we will be doing inside the emulator here also. Okay, so for this purpose we need a Frida server that is for what? There is Linux and there is Mac OS and there is Android. We surely know that this is an Android device. The emulator is an Android device, but it is based on x86. it can process Android based these two architectures. So it means the x86 that is here is based on Android. Okay, Android x86 is here, and there is x86 64. If there is an LD player advanced version for you, which is a 64-bit, then you should download this version. Okay, the other thing like FreeBSD, Linux, and these are for other operating systems, like if you want to analyze Linux window, if you have Mac OS as a serving device, so these things can be used there. So go ahead and download Android x86 for this emulator. Or if you have a mobile phone, for example, and you have a 64-bit mobile phone, which is a standard, you have a modern phone, you will use this one. Okay, Android ARM64, right? I think this should be clear to you. There is no ambiguity in this thing. Download whatever server you want, and then push it with your MT manager to the location that I'm going to show you right now. To go to root directory and go to data, and go to local, and go to temporary. Here you will paste your server. I have this FX86 as a server. It is x86 and F is for Frida. I have renamed the name to avoid detection. There are multiple type of detections from different type of games. One of those is detecting Frida server here in this folder. Yes, the games are actually checking this folder for Frida server binary. If the name is Frida or it has server or something in its name, it will be detected, and then the game can behave in a different way. Also, you must know that the all permissions should be allowed. Okay, 777 permission is here. And after doing all of this, in your phone you should open a terminal. You should open Termux. Okay, in Termux you go to, you already have shell, but in Termux you must open super user based shell. Okay, which is a root based shell. And after that you go to cd data local temporary, and then just use fx86. If the permissions are not set on this server, it will not run properly. And the way you can verify if the permissions are set correctly, you just do chmod plus x and just give it the name of the server that you have. It will apply the permission for executable. It will allow executable for this, and then you can run it normally. The way you run it is by just calling its name with the / in front of it, so to notify to Termux or command prompt that it is a executable. After this is running, it won't show anything here to you. Okay, a modern Frida server shows IP address etc. here, that it is listening on port XYZ and it is listening on this address. But in PC side, like older versions of the Frida server won't show you anything. Okay, it is just here. When you see nothing, it means the server is running. The next step is to launch another command prompt here, another one, and now we must first verify if this command is seeing our device, and the emulator is seeing here. If you are in mobile phone, you don't need to run this command. You just launch another Termux window, and you already know if you swipe on the left side, you will see one, and then you can spawn another window of Termux. And in that next window, this is the old window of Termux, this is the new window of Termux. In new window you can run commands like Frida, etc, etc, whatever you want to. All commands start from Frida. In emulator side, however, when you want to run command, it requires you to have -U in front of it. The capitalization is important because if you type -u, it will be something different. If you type capital U, it will be different. If you type -l is different, capital L is different. Things like this. How you know which commands need to be applied? You can use help. Okay, I think the help is with like this. Yes, okay. The help is with double dash. I'm using different tools, so some tools requires slash, question mark, etc. So sometimes I get confused. So these are the arguments that can be passed, and these are the meanings of the arguments. Minus capital U, what does it mean? It means that the device is connected with USB with your PC. All emulators are considered as USB devices with debugging capabilities. This is why we will use minus capital U. Okay, there are other things like F. With small f means target, or it means spawn the file. File means the program. Spawn the program. So if there is an app like com.tencent.ig, we can tell Frida, before running anything, first start the application for us and then do everything you want to do. There are other things like RAM. RAM means native and emulated. So in mobile phone you don't need to use this. In PC we need to use this to tell Frida that you are going to communicate with a device that is emulator, that it is not a native device, it is an emulating device. So there are some things that could be different from normal standard devices, like the registers, representations, the program counters, the instruction pointers, etc. Those things are going to be differently represented inside the emulator. Also, you have scripting capabilities. You can start Frida with a script. You write your own script and you load it inside the emulator, and the script will do whatever you want it to do with this application or this application or this or whatever you want to do, right? So as the Frida server is now running, we cannot close the window. We just need to minimize it, and we will keep it on one side of our PC screen. In the other side, we can issue the first command to know if the Frida connection is successful. You just do Frida minus U or Frida dash PS minus capital U. Okay, this means to show me the PS command, the PM command or the AM command inside Android devices, that shows you a list of running processes. And we are telling it that you are going to communicate with a USB device. So this is the first command that I always do to verify if the connection is correctly working or not working. After running this command, you should be able to see all the applications or programs running right now inside the emulator. See, we are doing com.something, camera server, audio server. This is the process identification number of the application that is running. For example, Google Play Games and Store are running in the background with these. LD Store is running with this PID and other things. ADBD is the bridge that is communicating with our PC, is running on this PID. And there are like super user and SH shell is running on these PIDs. Zygote is running on this, etc, etc. You already know most of these things. FX86 is the Frida server that is running on this PID. If we kill it, we kill this PID, then this server will close automatically. This means now that the Frida has been installed successfully inside the emulator. The second step that so this process is for rooted devices in mobile phone as well as in PC. The second step that I wanted to talk to you about is if you don't have a rooted device, how you will be able to use it. This requires mod APK creation. Okay, as we know, we make mod APK and we can insert our library inside and we can spawn it and we can run it without any problem. There is a tutorial, I will link to this so that you can know how to create your own mod APK and how to launch Frida inside. But I don't prefer for you to use the mod APK version. The rooted device version is a lot better. And if you go search how to create Frida like this, let me show you. There is Frida gadget injection tutorial on Android, no root. Okay, this is the link. You can see it from the window, from the video here, and I will also post it inside the group. So there are methods like the first one is to decompile the application and then use it. And the other one is that system.load library method we use in modapk. Okay, so the method 2 is from here. We use this constant string Frida gadget invoke static. Your modapk creators already know these things, who create sign kills and who create these things. So you can open your own Frida gadget inside the modapk, and it is very easy. I will provide both 32-bit 64-bit binaries including Frida every season for you, so you can run it easily without any problem. How and which library you will be able to run if you have a 64-bit device? You already know, I told you about Frida servers, but if you are going to run it inside modapk, then you need a library .so. Okay, and .so is called Frida gadget, and the Frida gadget is, I think, here. These are all .so. You already know these are static libraries, shared objects. So Frida gadget for Android ARM64, and this is for x86 versions, and this is for normal ARM, the old Android devices. So you just download this one, Frida gadget, and then push it into the modapk inside the game that you are going to analyze, and you just put these things anywhere in the sign kill, like in the factory stub. If you are using lspatch, you need to put these in factory stub. If you are using other sign killer like mtvip and other things, then there are places where you can put these strings and load your library, right? In both cases, the method of analyzing the game etc stays the same. You can use scripts which will make the process very fast, and you can use normal analysis with using commands from Frida. It will be harder, but it will still work. And there are Frida tutorials online, like Frida manual. If you go online, there is Frida handbook here. There is the standard official Frida framework introduction. Hacktricks website already also shows a few things or scripts that you can use. This is the handbook, how to use JavaScripts, how to use stalker, how to use hooks and interception. All these things are already here, and I like this one because it shows everything in a concise manner in one page. For example, if we are analyzing Android, here is a complete script that you can use for doing what? Java.perform some function. This is some main activity that it is going to hook on click. If you are clicking somewhere and then the click value is saved and console shows you the clicks etc. There are other things like you can do with Java Bridge, like many examples here. Stake trace, how to use stake trace. Also, if you are on Windows, sorry, if you are on Android, and the tutorials are here, like trace open calls. This is small script that you can use. Where is the script? It is it should be here. So there is no script. Yeah, so there is no script. It is showing as a command, and we will show this command right now, how to use it for this emulator. For example, this command I will copy from here, and I will go, and we already know that if I want to use anything, the U is important. Okay, and I means intercept calls for all open functions. Okay, and -n means they attach to this application, but we are not going to attach, we will spawn. F for spawn. We will tell Frida to spawn this application for us. -f, which application we are going to spawn? -f com.tencent.ig. okay, and we will watch our emulator here on the right corner. We will just do this. The open function is already intercepted, and it is showing us that whatever things it is going to open, it will show it to us, but we have not implemented anything yet. Now, what is the second step? We know that the open is intercepted and it is shown, the thread ID is shown, and everything is shown. That is important. That the tool thinks important, but it is not important yet. If you go to from where we are running our script, here if you go to the top, we are running this from this folder, Mr. Khan. Okay, we go to this folder in our PC, and in this PC we will see a folder created called handlers. Inside handlers is libc, and here is open. If you open this in notepad++, you will see this is a simple and automatically generated interceptor. Okay, the structure of the script is like this. These are comments. This is based on JavaScript, and we remove everything that we see here, and we are telling that if you are entering the open, you will show us in the log open only, nothing else. But there are other things, that is arguments, the state, and we can access these things. So let us imagine you are not like me who knows a little bit of JavaScript. You are somebody that doesn't know anything about anything. Okay, so you just copy everything from here. You spawn a ChatGPT session. Okay, today in the modern world it is the fastest way to create scripts or do whatever you want to do. Okay, and you see I have always been using this thing already in the past. So in here let's tell ChatGPT. The rule for ChatGPT usage is this, that you must be precise in your questioning. Your question should have detail, and if you don't provide detail, if you provide ambiguity, it will show you wrong information. So I'm asking it, I want to trace open calls in libc.so. An automatic handler has been created by Frida trace tool. I want to modify it in such a way that it shows me all file descriptors and the backtrace, which is formatted in such a way that the latest call is present on the rightmost and the original or the origin call is present on the leftmost in the same line as the file descriptor, or in single line after file descriptors and arguments are shown. This is the auto handler script. Okay, modify it for me, include what I told you. So now you see this is a beautifully created question. You can say I have provided detail, I have provided it what needs to be done, I have provided this is my base, I want to modify it to something. Okay, and I am telling it like I am talking to a servant. So it has created some script for me. I will just copy it, I will go to the auto handler. Okay, and I will save it. Forget everything now. Now you saw the open script that was the open handler was showing me all of these things. If I press up key here, up key is already always present in also present in termux, so you can press the up arrow above your keyboard and you can go to the previous command. If you do this again, PUBG will start again, and this time the open will not have simple calls, it will show detail whatever is happening inside the game. Okay, so now it is showing, for example, in the first open is called with path/dev/binder, file descriptor is 9, backtrace is this call was coming from what, the original call was from bootframework.oat and the final call was from libbinder.so. Before this was these symbols, libbinder with Android process state, app process 32, libandroid runtime, etc. these things. Okay, and the next call is from dev/ashmem, The next one is data local CFG app device, these things. Now there could be some problems here, like obviously this is an online game and this is not allowing you to trace everything. Okay, so we can remove file descriptor. We will just show the path and we will show the backtrace. Okay, we will remove the file descriptor from here, return value, so it is not important for us. Backtrace accurate, map debug symbol from address, reverse join called with path. Okay, this is fine now. And if we get a crash again, we will I will show you how to analyze the crash and how to stop it. Okay, okay, this is crashing again. Now the file descriptor has been stopped, the paths are coming to us. Okay, so the next thing that we might be interested in, how to study this crash. The crash shows me that this PID is causing 6segv. 6segv is for segmentation fault and signal for access error. The fault address is this one, and the backtrace shows which libraries are causing this crash for me. Okay, and this is how sometimes people can create crash fixes. So if you go from here, this is the latest PC and this is the oldest. This is the origin, this is the origin, and this is the latest. So kernel syscall has happened with 16 argument, and DL syscall was opening, and debugger D signal handler sig info PV. So the problem is coming from this program counter. It shows me that signal handler with debugger D signal, this is causing the crash, because after this syscall is called and the crash happens after this. Okay, and if you go to the older things like invoke user signal handler, so invoke user signal handler is fine, it is a part of app process 32, which is a part of the device, the Android system. But after this signal is caught, debugger D signal, debugger D is used for dbus, which is used by Frida for capturing signals, etc. So this is detected in the game and early on, and this is causing the crash. So we can create a handler for this to stop the detection of this and to fix the crash. Let me pause the video and I will add the script for this inside, and I will then continue the video because this is an advanced topic, so I don't want you to see this right now early before time. So I have now created a script that we can use to intercept, open, as well as stop the crash that was happening in the previous version. The way the script works is you have JavaScript based functions and there are JavaScript based instructions that you are going to automatically launch. Okay, I will show it to you in detail in further lectures, but right now let's see what we were trying to do is feasible or not. So do the same script, Frida -u for USB and -l for script, and the script is called script lecture1.js, and you are going to spawn like before doing anything, let's sorry, there is a misclick here. Right click pastes everything that you have in the clipboard. Okay, before doing anything, we forgot to type one command. You are going to spawn 10-cent game, but you are also forgetting to type this thing, rem equal to emulated. This is important, and let's see if it is working without any problem or not. If it is still crashing, then we will apply this script. Oh, so I forgot that I was in the wrong directory. Let's go back. Let's try it again. So it looks like the game is crashing. There is some sort of detection that is happening and the game is not moving forward, right? We can try to spawn the game without the script to see, without the handler, to see what happens. Multiplayer is sometimes buggy, so we need to restart it from time to time. Alright, after restart you need to respawn the server. Go to su data local temporary /fx86. you come back here, but before doing anything, let's start PUBG. Okay, so it's going forward, but I think I have modified something inside the game. The bypass library is present, so it is possible that it was showing problem in the previous attempt. Let's do it now with the automatic handler of open.js. Yeah, it's working now perfectly. Oh, okay, so it is crashing again. This means bad access is happening again. 6segue is happening. It is a segmentation fault, a mapper fault. Okay, all these faults are handled from a debugger D signal, as we talked about, and debugger D signal can be bypassed with a script that we have created just a short while ago. Now this time we will do Frida -u -l for the script that we just created, and we will do -f for spawning com.tencent.org, and we will tell it that we are inside emulated environment. Okay, make sure that PUBG is not running, everything is default. You just click enter. com.tencent.org. tencent.org. There is an error in my script on line number 80. Current debugger D with backtrace. Return value should be I think this is fine. The open is not working now. Let me modify the script a little bit. So now the problem was corrected. The library linker did not have this debugger signal. It was showing wrong in the backtrace when the crash happened. It was a part of libdebugger d client.so when I searched it inside the emulator, and then the debugger call was intercepted from there and I stopped it. We will talk about all of these things that we will talk about all of these things in the coming lectures. This is just an introduction to show you just a taste of what Frida can do. So right now, when the script has been finalized, we can spawn another session, and we are trying to watch all open calls, and the descriptor and the addresses, these are showing us wrong. We will do a small change here to give us exact location from which library and which offset these are starting. It is in fact coming right here, but I don't want this address. So if you go to the script and you see in the open intercept, you can see in the backtrace it is showing this dot context backtrace dot equate reverse the backtrace to have the origin call on the leftmost side. join with this to have the latest call on the rightmost side. Okay, backtrace and backtrace. So I think this is not going to cut the chase. We have our own script which we created in the past. We have a function called format backtrace. I will copy it from there onto this function that I'm using into this script. I will use it in the top of the script. I will use it in open here, constant backtrace. Instead of all these things, I will just do this dot context. Okay, now it should be fine. And the backtrace should just show me BT. Now let's clear the screen, restart again, and this is what we have been trying to look for. In fact, let me do one small adjustment to remove the this thing here, the file descriptor. This I don't want it. It should be here. Arguments, error reading path, file descriptor here. Okay, so I don't need this. I will remove it. And the backtrace is here. Console.log with this. Okay, everything is fine. Now let me just show you one last thing, then we will conclude this lecture. Now the game is starting, and boom, we can see all the calls happening from all the libraries and all the offsets, checking for which path, TTM, KB log, everything. You can see from which libraries they are starting, like libc data master is checking this thing. Okay, similarly, the debugger dsignal handler is again coming. So I think we need this intercept to work, but it would require some small things to adjust. Let me adjust this in the background to stop wasting your time. And so after having dinner and changing some small things in the script, adding signal handler for removing crash, added case 16 to avoid detection of Frida, we now have a working solution. And also, when Frida here is touched, we are using stalker to follow the function and find from which locations the calls were originating or starting. And after that, when the call was done, what was happening to the next calls, like which functions were running after that. So here we say libanogs, this function, this one, and this one is running after the Frida is called in case 16. This is stalker is one of the many functionalities of Frida. Stalker basically means you can follow a thread or a function, whichever functions that thread is going to call later on, it will be displayed to you. Whenever you want to use stalker, you can just attach it to a thread and it will follow it. Similarly, this signal has come again from this time it is again from like last time, it is again from debugger dsignal handler, and the signal is again signal 11. If you go up in this log that we have just taken in our console, you will see that we are already intercepting and handling signal number 11, which is a segmentation fault. So obviously this is not coming directly from signal 11, but it is maybe from a kernel syscall or some other syscall that is hidden by the game. There are some easy ways to remove the detection of Frida, both from case 16, but there is another version. We have discussed it inside the group, how to remove the detection of Frida. So I will first remove the stalker from here, because it could be one of the reasons that is causing the crash. Stalker.follow this version, we will remove it from case 16. Next thing, we will test this once again. If the crash is not removed, then we will implement the last detection removing mechanism from case from string. It is basically from string. We remove all mentions to Frida and such things from libnogs. As you can see, it is working pretty much stable as compared to the first time we attempted, as you saw in the video. And I'm doing this all live in front of you. I'm also actively using ChatGPT for removing syntax errors from my JavaScript and also to save time. Here you can see the segmentation fault should come here and the game should crash, but it is intercepting, returning 0, and then the rest of the thing is working without any crash. After some time, if it still causes crash near case 16, then it is from case 16 and we will stop it from there. If after modifying case 16 it is still causing crash, then the last option is to use string to remove any mention of Frida from any comparisons. There are other ways also to remove it from string length and from other things, like following with backtrace strings that are mentioning Frida and then stopping those functions in anodes or in other libraries that are causing the detection. So right now it's decently fine. Let's wait for case 16 to hit. We will know if the game will crash or not with Frida. Anti-Frida returning 0 here. So until now, no crash maybe. Another case 16 returning 0. Code scan, Frida scan returning 0. So yeah, the crash has been removed and there is no problem in the script whatsoever. Okay. This is an old idea. On 21 August it was banned and now it is 28th August, so this is not from the script. Script will not ban your game or ID. Okay. Right, so these are the logs and how to use Frida, the basic functionalities of using Frida. You can take the log from here. Okay, that's fine, we can do it until the start. You can take it to a notepad file and what we can do here is we will search for Mr. on somewhere here so that we can know from where the script started. So it started from here. This is the complete log. Now we can just make it more readable, like whenever we see this thing and there is a /n/r/n before it, we can check it. Yeah, so we can remove that and we can just put with the bt. We can replace all. It is more readable now. Called with path can be removed, like you can do this. You can remove it with a space. Okay. What else? Forbidden thread detected, returning 0. This can also be removed completely. We don't need it because there is no backtrace attached to it. Also the video is pretty much lengthy, about 1 hour now. We will make it shorter. These files, these lines are not important. We can remove it. We can remove these things. Can remove these things. Okay. Okay, these are also not important. Let's see what else junk can we remove. Intercepting can also be removed. What else? Signal handling can also be removed. We can just remove those lines. What else? Like these things can also be removed. Alright, so this is the open log for emulators for LD player. Okay, and then we can do remove duplicate lines, okay, to make it simplified, and we can put it in ascending order in lexicographical, okay, like this. But you can keep it as original format to see which functions are running in the start, which in the end, etc, etc. So the first thing that you see is checking for CPU info, and it starts from libuE4 plus this function. You can go to that thing here, the function here, let it decompile. This is basically from this call, and you can see here proc CPU info. Proc CPU info is from this. So the CPU info is checked in this function and then later on forwarded. And when this function runs, if the CPU info is present, then it will return something. Open, you can see in in internet, you can just see open libc man for manual, okay, man page or man for manual, and you can see the open has a return value of what? Return 0 will be on success. Open it and create returns the new file descriptor. It will return a file descriptor. On error, -1 is returned and error number is set to indicate the error. Okay, so you can just return -1 here or something if you want to block libuE4 from checking CPU info, or you can hook it there and modify, hook and modify and give it fake info from another device. It's up to you. System CPU present or possible. What else? Auxv, this is gcloud SDK log, runs from here. So anything that is running from libc.so is probably mostly from syscalls. That's why the backtrace has not been constructed properly, right? And because libc on itself doesn't care about these things, but some other function is calling libc to do the work for them and return the value. So there are some things that are preventing proper backtrace, like checking, and one of those are sigproc mask. Okay, sigproc mask. We will talk about this in later lectures, how to remove that proc mask, processor masking, or command masking. We will talk about how to remove it, and we will make a script, and we will reconstruct these and revisit these function and reconstruct the backtrace. Okay. Similarly, there are some things like user custom, user settings. You know which functions are calling or accessing those things. Okay, which functions are accessing those files. Similarly, light data, source version. You see the source version is checked by, and in fact it is checked by a lot of things. A lot of files are checked by the same function, so it is no use if you want to check it from here. There is login backup, last country number, e-login data saved here, accessed by same function. Then there is libtgpa. These two functions checking SD card /zzz. Okay, and there are some other SSS, QQQ. These functions are just to check for emulators or other things, maybe, I don't know. So an active save, these functions were used in the past. These files were used in the past to save and modify the configuration of the game. There are many things that you can check: buffer list, game error, no records, in reason, restart game, e-login data, itop preferences, agree, illegal avatar rule. Map files are checked from here, and libanox is checking these things. What pipe sec, this notifies the game if it is an emulator or not, okay, because in game loop this thing is present, but in LD player etc this is not present. So you can just go to libanox in 3.3, go to this function, you see open is called from here. Open is called from here, this function. And before calling it, this function is called. It is doing some calculations or some hidden stuff. I don't know about these things mostly. Maybe that was looks like a decryptor function. Is there a key following here? Wait, yes, there is a key here, key, and so this function is decrypt string, okay. It decrypts a certain string, and then that string is saved in R0 and forwarded to open as a path. When this decrypt string works with this key 6516, okay, so this will generate what? This will generate this string, dev/wordpipe/sec, okay. The key for that is this number. This because it is not constructed properly, so that's why it is not synchronizing. But if you go to other, so the open is called, the value returned is saved again in R0, and then R0 is checked in this location. Compare R5 and compare R0 value, go to this. The file descriptor is checked, and then other things are done here. This square bracket means as a pointer, go to that thing and use it as a pointer and use it. And what else? So yeah, pretty much those things. Open is called from this function with this decrypt string, so you can go up to the top of this function here, and then you can block this to disable checking of dev word pipe, okay. So emulator users already know how this is important check for game loop, okay. 91714, and how you can stop the check, and you already know this is using the JXSV table, and then using time, and then using other things, and returning A1. A1 is what? The vtable that has been passed to it. It is modified a little bit and then returned. So you can return 0 from here to completely stop the check, or you can do a smart hook and modify the vtable according to your own knowledge, but it requires time and study. Similar things from libanox is dev/kgsl3do. It is in some emulators, but not in all emulators. It is in Phoenix or Game Loop, one of those. You can go to this and you will see similar structure as I explained to you. Go to this new function RealXR4. This is calling R4. It is calling open. Okay, this is calling v28 is equal to open. This is open function, and it is forwarding these, I don't know, things to these parameters to this open, but the parameters are 3, I think, not more, or 2. I think 2, yes. The mode and the file descriptor. Path name flags, yeah, but more are also path name flags and some other mode, yes. So there can be more parameters passed. So this is open, and after open there is these functions, msr, pop, and go jump to this location. And they are also not encrypting the string. Maybe they are taking it from the stake or something, I don't know. Yeah, they are taking the string from the stake, the stake pointer analysis and things from stake. So they're jumping to open. There are like in this one, you can stop it from here, 12f 5d4, and it will stop the check for, you know, or you can do this. Checks for this. You can save the database for your own analysis. Similarly, let's go and see more things like what else is libanox checking. Also libnrt is checking for libanox.so library. Is it present in this folder or not? Okay. libue4, this location is checking for auxv. We already talked about it. So yeah, this is just a small and brief introduction of how you can take logs with Frida without writing any C++ code or pushing library or anything, or everything from the outside. And you will face crashes for Frida. You can remove it, you can take logs, and you can use it for your own advantage. This is just one function open. In libanox, you can, in libanox or in libc, you can hook all these functions. You see most of those are in external, but if you go to plt segment, this plt segment, all these functions you can hook easily, and then you can study them and use backtrace to find functions running inside the game. In a few lectures later we will talk about this. So in the group, in our team, these are the video courses that I was going to post, but I instead recorded a long video covering many topics. How to install and set up a device for Frida usage, this is done. How to connect to Frida, this is done. The connection is made with normal Frida -u or normal Frida, depending on which architecture you are going to analyze. The script is done, interception is done, onLeave and onEnter you saw in the script. You can experiment on those in detail. I will provide the script. In the next lectures we will talk about pattern scans and interceptions based on RVAs, function interception, hex dumps, and then bypassing. I already bypassed Frida detection in this script in the previous 1 hour of this recording of this video, or 2 hours, because I was taking breaks. I already intercepted, but I will teach how to do this on your own in other games, inshallah. So these 4 lectures are done. The next lecture will be posted 1 week later. Depending on my schedule, I will try to be faster. Okay. Fi amanillah, Allah Hafiz. Best wishes in your learning journey. Goodbye.